Welcome to this episode of Robert's Creative Chronicles. So today, I'm going to be teaching you about supernode analysis. Now, here is the circuit. In this circuit, first of all, what is a supernode? A supernode is constituted by two adjacent nodes that are sharing a common voltage source. For instance, V2, this node 2 and node 3, they are sharing a common voltage source. They are sharing a common voltage source, Vx. So these two nodes now constitute supernode. So this kind of analysis, you have to identify the principal nodes before you start doing the analysis. So the first step is to identify the position of voltage source. Here, the voltage source is common to the two. So the first step in doing supernode analysis is to identify the position of voltage source. Here, the voltage source is common to the two nodes, 2 and 3. So supernode is nothing but the combination of node 2 and 3. As I said before, a supernode is the combination of this node 2 and node 3. And they are both principal nodes. So the second step, apply KCL to supernode and to other nodes. So applying KCL to supernode, that is combination of node 2 and 3, we get V2 minus V1 over R2. So now, if you apply the KCL to this supernode, you are going to start the analysis, but the first thing you are going to consider is the voltages of this supernode. Unlike the normal way we do before, that we'll be going from here, maybe a voltage here minus this, then we'll be moving from left to right. In this one, that is in the normal node analysis. Unlike the normal way we do normal node analysis. This one, it is from the supernode that we'll start the analysis from. So instead of saying V1 minus V2 in this, when considering the supernode, we will say V2 minus V1 and V2 minus 0. The same way, we'll say V3 minus Vy, then V3 minus 0. The voltage at the bottom, which is the reference voltage or the reference potential, is 0 volts. So when we're applying KCL to this supernode, we will say V2 minus 0. Okay, let's start with here. So we'll say V2 minus V1 over R2. V2 minus V1 over R2 plus V2 minus 0 over R3. V2 over R3 plus V3 minus Vy over R4. V3 minus Vy over R4 plus what? V3 minus 0 over R5. V3 minus 0 over R5 equals to 0. So this is the case here. We have applied KCL and we have also applied Ohm's law in this. Normally it should be an equation of current first to be transferred into this voltage and resistance. But we have done it directly now. So this is how you do supernode analysis. When you apply KCL to the supernode, you start it from the supernode. It is the first thing you are going to consider. So instead of saying V1 minus V2, you are going to start from this supernode. This minus this, this minus this, this minus this, this minus this. So next, we are going to apply KCL to node 1. So if you apply KCL to node 1, this is the normal node analysis. So when I enters this node, it will divide here. A portion will enter here, R1, and a portion will enter R2. So applying KCL at this point, it's I equals to I plus I2. So I equals to I plus I2. Then if you apply Ohm's law, I1 is V1 minus 0 over R1. That's V1 minus 0 over R1. Then I2 is what? I2 is V1 minus V2 over R2. V1 minus V2 over R2. So that's all. Okay. So then the third step, make the relation between node voltage. Then the third step, make the relation between node voltages with voltage source to get the third equation. Third equation is nothing but the relation between Vx, V2 and V3, which is V2 minus V3 equals to Vx. So now you will make a relation between this voltage, the voltage between the two nodes that form the supernode. Now the voltage across here will be V2 minus V3. Because here is positive and here is negative. V2 is at a higher potential and V3 is at a lower potential, which is negative, and hence this one is positive because of the signs. So V2 and V3. So V2 is at a higher potential positive and V3 is at a lower potential negative. So it is the voltage across here is V2 minus V3 equals to, which is equals to Vx. So V2 minus V3, which is equals to Vx. So the fourth step, so the fourth and the final step, solve the above nodal equations to get the node voltages. So you solve these three simultaneous equations using any method you want, either Cramer's rule, elimination method, substitution method, matrix inversion method, any method you want to get your final answers, to get your node voltages. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.